Yo, what's good, guys? We're back with another video. Today, we're going to be over... What the fuck am I talking about? We're going to be going over integration by parts, which is usually a Calc 2 slash BC material. And it's kind of hard for some people, so I'll be breaking it down today. So first off, we have to recognize what is integration by parts. So if you're done with Calc 1 or AB, you probably know that integration is just area over something, right? And usually integration techniques from Calc 2 get significantly harder, and this is one of the first techniques you learn. So usually integration by parts is you have the integration of u dv of some sort of function. These two are functions, is equal to uv minus the integration of v du. And so essentially, the reason why you get this function is because you can derive it using a product rule. So look, let's say you have uv, right? Oh my god, I actually suck. Let me just say you have uv. So u is gonna be this, and then v is gonna be green. Why not? So then you have uv derivative equal to v prime u plus u prime then v. So essentially, the reason why this works is because you have uv prime is equal to the product rule, right? So then when you go to derive both of these functions, you have this cancels out, and then you can just do the rule where you can add the integration part. So you have uv is equal to the integration of v prime u, or dvu, u dv, plus v du. So essentially, how you can get this whole formula is just doing, since you want u dv, you have u dv, right? Which is this one. You just want to do uv minus v du equal to u dv. It's essentially where you get the whole formula from. And essentially, we're going to be using this formula in order to just learn about integration by parts and seeing how they work. So I'm going to change the color real quick because I don't like using black for everything. So the first example I'm going to use is going to be x cosine x dx. So essentially, since this is your general formula, since you have uv minus v du, you want to make something your u and you want to make something your v, and I mean your dv. And when you have dv, you're going to integrate to get v. Here's what I mean. For this one, we're going to use u is equal to x. Pretty simple, right? And then du is equal to 1. So then you have dv. You know, I'm gonna start using some colors. We're going to have dv equal to cosine of x. And then v is going to equal to sine of x. So essentially, since our formula is uv minus v du for the integration by parts, what you can do is you can actually just do this and then just plug in for your formula. So for this case, we'll get uv. So u is x, and then v is sine of x. So you'll get x sine of x minus v, which is sine of x, du, which is 1. So really you just have dx. And then from here, your answer is x sine of x plus cosine of x plus c. Don't forget your plus c. And essentially, that's just what integration by parts is. And here's the proof that it works. So essentially, you have x sine of x plus cosine of x, right? Plus c as your integration. So we were to derive or take the derivative of this function, we should be able to get x cosine x. So I'm going to show you how. Cosine of x derivative is just negative sine of x. And then from here, we can do product rule for x sine of x So essentially we have x cosine of x plus sine of x, and this is your product rule because x derivative is just 1. And then you can just add in this one minus sine of x, and these cancel, leaving you with x cosine of x. So math works. Math definitely works. So this is essentially your proof as to why integration by parts works. So now we're going to go into a rather more difficult example, I would say. We have natural log of x dx. Now, looking at this, you might be wondering, well, what the fuck? Why do I not have two functions? What? Blah, 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 blah. And you might be wondering, yeah, it seems like you don't have two functions, but you do. No, you do. I'm not bullshitting. No, you do. It's just that, unfortunately, mathematicians really are fucking lazy. I don't know why. And they expect you to know this one right here. Because it's a one. It's a secret one. So essentially, you have u, and then you have your dv. Oh my god, let me just change the color real quick. So essentially, your dv's is going to be 1. And then you can integrate this v to be x. And then from here, your u is going to be natural log of x. Because again, you don't know how to integrate natural log of x. I don't even know how to fucking integrate. It's been a minute since I've done it. But you do know your du, or your derivative of natural log of x, which is just 1 over x. And so from here, we pull out a formula again of, what was it? Look, you forgot. uv minus v du. So you can just plug in. U is natural log of x, v is x. So it's just going to be x natural log of x minus your v. V, in this case, is going to be x. Du is going to be 1 over x dx. And then from here, you can see that these x's cancel. So you just have x natural log of x minus dx, essentially. But, you still keep that circular 1. So essentially from here, you can just integrate by 1. And your answer is going to be x natural log of x minus x plus c, which is your answer. So now we're going to go into an example that I really like, because you're going to be like, what the fuck? You didn't teach me this. Or my calculus teacher didn't teach me this. Which he most certainly will. But I'm just going over it because I like it. So essentially, we're going to go over a method called tabular method. And here's how it goes. You see that we have the integral of x to the third e to the x dx. From here, we can do integration by parts because it works. And mostly, if you don't want to do this method because you don't remember it, then it's safer to do it via the route you just learned. However, if you want to go for a shortcut method, highly recommend you do this if you're able to remember the formula. So essentially, you're going to do the same thing here. You pick out your u and you pick out your dv. Essentially, you want to make your u as less complicated as possible. I mean your dv, because you don't want to integrate a hard function for dv. So essentially, I'm going to choose dv is equal to e of x, because your v is then e to the x. U for this one is going to be x to the third, and then du is going to be 3x squared. But here's the fun part. We're not going to follow this. We're not going to follow this one. No, you can definitely do this, but we're not going to do that, though. What we're going to do is we're going to set up a little chart, which is why it's called tabular method. And we're going to write out u and dv. So essentially, for tabular method, what you want to do is you just want to take the derivative of u all the way until it reaches 0. And I'm going to show you why, for me personally, I only do this if there's a polynomial on it. And here's why. So essentially, you have this, right? So then you're just going to do 3x squared 6x, 6, and then 0. Then for e to the x, or for dv, you're just going to take the integral of it. So essentially it's just going to be e to the x, e to the x, e to the x, and e to the x. And from there, you're going to pair it up like so. Oh my god, I'm trying to get the red one. And so essentially you're going to have 4 pairings. And from here, you're going to write a positive, a negative, a positive, and a negative. And essentially, what you're going to do is you're just going to pair them up. So essentially, the integral for x to the third e to the x is x to the third e to the x minus 3x squared e to the x plus 6x e to the x minus 6x e to the x plus c. And that's your integral. So essentially, tabular method with polynomials is a quick and easy way to get an integral like this without having to do the whole u, dv, and formula, because you can do it for sure. It just takes a much longer time, and when you're in a crunch on the BC exam, you honestly don't have that much time. So, if you're able to remember this formula by tabular method, then for all means, go for it. You just have to do it right. And so this brings me to my last question, which is going to be a fucking challenging one. Even for me, I get confused on some of these things because they're hard, and I'm teaching it to you, so I kind of have to be perfect, or else you're gonna be like, boo, boo this man, boo, he don't know what the fuck he's talking about. But I promise you, I do. So for my last question, we are going to do e to the negative x sine of 2x dx. We're going to take the integral of this one. So essentially, you can't really do tabular method with this one because you don't have a polynomial. And even if you were to use tabular method, you can, but it's so much more complicated. So I'm just going to show you the old-fashioned way. We're going to use formula by parts. Yay! And you might be wondering, boo, I don't want to do this shit anymore. Well, too bad, so sad. You clicked on this video because you're either struggling or you're just a nerd. So I don't know. Pick one. Pick a struggle. Essentially, what we're going to do is we're going to pick u as sine of 2x. And then we're going to do dv as e to the negative x. The reason why I picked u as sine of 2x and not dv is because I'm not integrating that. I just don't want to. It's so much easier to take the derivative of it. I just can't be asked. You know what I mean? And so we know that du is going... I just spit all over my screen. That's disgusting. But essentially, du is going to be 2 cosine of 2x. And then v's is going to be negative e to the negative x. So essentially what you can do is formula uv minus v du. Oh my god, I remember by memory this time. And essentially we're just going to do this, right? Doesn't look that hard. U is sine of 2x. V is negative e to the negative x. So you have negative 2 e to the negative x sine... I messed up. I'm sorry. I was looking at the other one. But essentially, your u is sine of 2x. And then your v is negative e to the negative x. So you're going to do this. And then minus v, which in this case is... You can actually just add them, I believe. Yeah, you can. Because you have negative e to negative x. Then du, which is 2 cosine of 2x dx. Now, essentially what you can do here is you can really just add them because you can just do this. You can take out the negative. So essentially now you have negative e to the x, negative x, I am so sorry. Do not forget your negative. Sine of 2x plus the integral of e to the negative x 2 cosine 2x dx. And essentially you're going to be like, well, what, you didn't give us the answer. And yeah, you're right. We're gonna have to do integration by parts again. Yeah, this is a tedious thingy. I don't know what y'all expected. This shit is not easy. But essentially, we're gonna do the same thing again. We're gonna make u2 cosine 2x, and then du is gonna be negative 4 sine of 2x. And then this time, dv is going to be the same, e to the negative x. V is negative e to negative x. And so essentially, since we only need to integrate this part again, what we have is really, we don't have to do anything with this one. I mean, we can just leave it. We're just integrating the second part. So essentially, we're going to have negative e to negative x sine of 2x. And then we're going to use our formula uv minus v du, which is going to be uv, which is what? Negative e to negative x 2 cosine of 2x minus v, which is negative e to the negative x du, which is negative 4 sine of 2x dx. So essentially, this is still a negative, so this just turns into negative e negative x sine of 2x minus e to negative x, has an x, 2 cosine 2x minus e to negative x, 4 sine 2x dx. And you're wondering, well, what the fuck? You didn't give us an answer, man. You're fucking fake. And I say to you, no, brother. No, because this is the amazing thing. With formulas, since you have something that says that u dv is equal to uv minus integration of v du, the amazing thing is we can go back to the original function. Yeah, now you're seeing it. So really, I'm just going to take this 4 out because you're just multiplying the whole thing by 4. And essentially what I'm going to do is I'm going to set it up equal to our original function. Dun, dun, dun. What the fuck? How did he do that? Oh my god. He's a fucking genius. No, I'm not really a genius. I'm just fucking lonely. But anyway, yeah, you can do that. You can actually set up the original function with the new function that we have in order to integrate it. And here's why it works. Essentially, it's a formula. That means that when you have these two opposites, they're the same thing essentially. So now you can solve this function like a little equation, like back in algebra 1. And since I took out the 4 because it's multiplying e to the negative x sine of 2x, you can take out the 4. And then you can just add this over as if like a variable. I'm being serious. Now you have 5 integral of e to negative x sine of 2x equal to negative e negative x sine of 2x minus e to negative x 2 cosine of 2x. And essentially, since you want to isolate the variable and we're trying to find this function and what the integral is, you can just divide by 5. And since we have isolated our variable, essentially, we know that the integral of e to negative x sine of 2x is equal to negative e negative x sine of 2x minus e to negative x 2 cosine of 2x over 5 plus e. And it's honestly incredible because you wouldn't ever expect your algebra basics to come back. But hey, guess what? Review a little bit of your algebra. It's cool, okay? Essentially, that's the way you do this problem. This is a real monster of a problem. I don't even know if this is right myself. But essentially, this is how you work through problems. This is how you work through integration by parts. Thank you for watching. If you've enjoyed, you've learned something, please leave a like. It benefits me a lot. Thank you for watching. This has been Integration by Parts. And goodbye.